This is chemistry for grade 12.
Hello students, this is chemistry for grade 12, presented by Tsagasmaro. Students, our today's lesson is industrial application of electrolysis. Students, please open your textbook on page 183. In this topic, we are going to discuss the several industrial applications of electrolysis. We will explain the electroplating and electron refining process and their uses. We will also see how electrolysis is used in the production of metals, nonmetals, and compounds. To get started, we will do an overview of electrolysis. Students, what is electrolysis? Electrolysis is a process that uses a direct electrical current to create chemical reactions. Electrodes are labeled as the anode and the cathode. They are connected to an external circuit that provides a source of electricity. The electrodes also provides the addition and the removal of electrons from the ions. Each electrode attracts ions that have a charge opposite to their own. Thus, a positively charged ions or cations move towards the electron adding a cathode, and the negatively charged ions or anions move to anode. During electrolysis, anions migrate to anode and discharged by losing electrons, so that oxidation takes place at anode. Cations migrate to cathode and discharged by gaining electrons, so that reduction takes place at cathode. So, during electrolysis, oxidation takes place at anode, while reduction takes place at cathode. Students, the industrial application of electrolysis are electroplating, electron refining, extraction of metals, production of nonmetals, and some other compounds. So, we will see these applications one by one. Electroplating. Electroplating is a process of coating or covering the surface of a metal with a thin layer of another metal. It is the coating of less active metal on the surface of more active metal by electrolysis. During electroplating, plating metal is used as an anode. Metal to be plated is used as a cathode. The electrolytic solution should contain the salt of plating metal. Electroplating is used to protect from corrosion, to give metals pleasant and colored appearances, to plate for metals having scratches. Example, galvanizing is plating a metal with zinc. Chrome plating is electrolytic deposition of chromium on other metals. Tin plating is the electrolytic deposition of tin on other metals. Students, now it is time to do an activity. Be ready. Activity 1. Where do we put the plating metal and the metal to be plated during electroplating? Where do we put the plating metal and the metal to be plated during electroplating? Activity 2. For electroplating of spoon made of iron with silver, identify the anode, cathode, and the electrolyte. For electroplating of spoon made of iron with silver, identify the anode, cathode, and the electrolyte. Students, now do the activities. Have you done the activities? Well, answer for activity 1. During electroplating, the plating metal is placed on anode, while the metal to be plated is on cathode. And the answer for activity 2 is silver is used as an anode, spodumene is used as cathode, and silver nitrate is used as an electrolyte. Because in electroplating process, the electrolyte should contain the salt of plating metal. Students, I will proceed industrial application of electrolysis, which is electron refining of metals. Students, I will proceed to electron refining of metals. Electron refining of metal is the purification of metals by electrolysis. During electron refining of metals, the impure metal is used as anode and the pure metal is used as cathode. The electrolyte in the electrolyte should contain the salt of the metal. Example, in the refining process of copper, the impure copper is used as anode, copper metal of high purity is used as cathode, and copper sulfate solution is the electrolyte in the process. When electrolysis is carried out, copper and the impurities that are more easily oxidized than copper will go into the solution. Copper passes through the solution and deposits on cathode, while the impurities remain in the solution. During electron refining process, the size of the impure metal anode decreases and that of pure copper cathode increases. Students, let us do an activity. In the electron refining copper metal, what does the electrolyte contain? In the electron refining of copper metal, what does the electrolyte contain? Students, have we done the activity? Well, the electrolyte will contain pure copper ion or copper sulfate solution because in the electron refining process, the electrolyte should contain the salt of the metal to be refined or purified. Extraction of metals. Extraction of metals is another application of electrolysis. Metals can be extracted by electrolysis. Alkaline metals, alkaline earth metals, and aluminum are manufactured by electrolytic reduction because they cannot be reduced by other reducing agents like carbon dioxide. They are better reducing agents than other reducing agents. The aluminum metal is extracted industrially by Hall process. The Hall process involves the electrolysis of molten alumina or aluminum oxide with some amount of cryolite. Cryolite is a salt that contains the elements sodium, aluminum, and fluorine, having a molecular formula of Na3Al(F6), and it is used to reduce the melting point of alumina from 2000 degrees centigrade to 1000 degrees centigrade. The vessel holding the mixture is made up of iron, which serve as cathode, and graphite or carbon rods serve as anode are inserted into the melt. When the molten mixture is electrolyzed, pure aluminum is produced. Now, there is another activity for you students. During the whole process in the production of aluminum metal, what material is used as an electrolyte? During the whole process in the production of aluminum metal, what material is used as an electrolyte? Students, if your answer is a mixture of aluminum oxide and cryolite, you are correct. Students, the other industrial application of electrolysis is production of nonmetals and some compounds. The nonmetals like hydrogen, chlorine, and fluorine are manufactured on an industrial scale by electrolysis process. The production of chemicals like sodium hydroxide is from the electrolysis of brine or concentrated sodium chloride solution using inert electrodes. In the electrolysis of concentrated sodium chloride solution, the solution contains sodium ion, chlorine ion, hydrogen ion, and OH ions. However, the concentration of hydrogen ion and OH ions are very small because the solution is concentrated. At the cathode, hydrogen ions are preferentially discharged in preference to sodium ion. Chlorine ions are discharged as the anode in preference to OH ions because the concentration of chlorine ion is very high. At the cathode reaction, in which reduction takes place, twice of hydrogen ion plus 2 electrons, it gives hydrogen gas. At anode reaction, in which oxidation takes place, twice of chlorine ion gives chlorine gas plus 2 electrons. The overall reaction will be twice of hydrogen ion plus twice of chlorine ion gives hydrogen gas plus chlorine gas. Students, remember that the overall reaction is the sum of the anode and cathode reactions. Since the sodium ion and OH ions remain in the solution yields sodium hydroxide. So, sodium hydroxide is produced by electrolysis. Students, please, I will ask you summary questions. Be ready. In the electrolysis of concentrated sodium chloride solution, based on the above idea, answer the following question. A. Which gas is produced at cathode? Which gas is produced at cathode? B. Which gas is produced at the anode? Which gas is produced at the anode? C. Which compound is remained in the solution? Which compound is remained in the solution? Students, have you answered the questions? Well, A. Hydrogen gas is produced at cathode because hydrogen is preferentially discharged than sodium, since hydrogen is below sodium in electrochemical series. I will repeat the answer. Hydrogen gas is produced at cathode because hydrogen is preferentially discharged than sodium ion, since hydrogen is below sodium in electrochemical series. B. Chlorine gas is produced at anode because chlorine ion is preferentially discharged than OH ion, since the concentration of chlorine ion is very high. I will repeat the answer. Chlorine gas is produced at anode because chlorine ion is preferentially discharged than OH ion, since the concentration of chlorine ion is very high. The answer for C is sodium hydroxide solution is remained in the solution because hydrogen and chlorine are liberated to cathode and anode respectively. I will repeat the answer. Sodium hydroxide solution is remained in the solution because hydrogen and chlorine are liberated to cathode and anode respectively. Students, in this lesson, we have covered that the industrial application of electrolysis are electroplating, electron refining, extraction of metals, production of nonmetals, and other compounds. Electroplating is the coating of less active metal on the surface of more active metal by electrolysis. Electroplating is used to protect from corrosion, to have metals pleasant appearance, and to plate for scratch metals. Electron refining of metals is a process of purification of metals by electrolysis. The main purpose of electron refining is to purify metals. During electron refining, impure metal is as anode and the pure metal is as cathode. Alkaline earth metals and aluminum metal are manufactured by electrolytic reduction. Non-metals like chlorine, hydrogen and fluorine are manufactured industrial scale by electrolysis process. Compounds such as sodium hydroxide are also produced by the process of electrolysis. Students, this is all for today. Next week we will meet with a new topic, galvanic cell. Until next time, goodbye.